The number of electrons lost or gained is directly related to the charge, which is written superscript to the right of the symbol. So those charges are directly related to the number of electrons gained or lost, not the number of protons. So in a neutral atom, you have the same number of protons, which are positive, and the same number of electrons. They balance each other out. They cancel each other out, those charges do. But when you have a net charge of either negative or positive, it's because you have gained or lost electrons. Right? So you can't change the number of protons, otherwise you're changing the identity of that element. Alright, so how do we get a 1 negative charge? We must have gained. Now students sometimes see a negative there and say, well, negative means you're losing electrons. No, it's not like that. This is the charge, and so you can only manipulate the number of electrons. You must have gained 1 electron to become 1 negatively charged. And so that's what all the halogens want to do. All these elements here are 1 column away, 1 spot away from their noble gas, or their nearest noble gas, and so they're all going to tend to gain 1 electron. All right, let's move on to B. Sodium is an alkali metal, so all alkali metals have 1 valence electron in their s orbital. 1 valence electron. And what was it? Sodium? Sodium, right there. All right, so by losing 1, right, so that's why their ionization energies are so low. It doesn't require as much, nearly as much as the elements to the right of the periodic table. All right, it's going to readily lose that 1 electron to have the same electron configuration as its nearest noble gas, which is 1 spot before it, in this case neon. So that's why they generally have a 1 positive charge, because they lose 1 electron. They have 1 valence electron to lose. Okay. Arsenic. Well, why don't you try this one? This one needs to gain 3 electrons. Where would you expect to see or find arsenic on the periodic table? It has to gain 3 electrons. Hopefully you're saying 3 columns away from the noble gases on the right side of the periodic table, right? So here are your group 15s. So if you have 5 valence electrons, there's arsenic, by the way. It must 1, 2, 3. That's why you're looking 3 columns away. All right, to look like krypton in arsenic's case. All right, barium, it's going to want to lose 2 electrons to become 2 positive. You lose negative particles, you end up with a net positive balance. So 2 electrons lost. So where do you think barium is on the periodic table? Right, it's 2 columns away from a noble gas, right? So now it's all the way over here to the left side. 1, 2, it loses that. It's going to look like xenon, its nearest noble gas. You get the hang of this. Not too bad. Let me go back to, just cycle back these colors. Well, that was the same reason, right? 2 negative. I'm sorry, 2 positive. So you lose in 2 electrons. Copper. This one's I can add a little bit to this one. Copper is a 1 positive, and let's just do both of these here. Copper is a transition metal, so a lot of transition metals have multiple cations. And the reason here is copper is an exception to the Aufbau. Kind of hard to show you this without a electron configuration. But copper's electron configuration is, this is 1, 2, 3, 4, right? So it's 4, 4s. You might say 4s2, and then 3d, because this is your d block. 3d9, because it's in the 9th spot. But actually, that's what you would get if you follow Aufbau. One of these electrons gets promoted, right, to the d orbital, to get that d orbital full at the expense of the one of the at the s orbital. All right. Anyway, now you can see why it's common for it to lose 1 electron. right? It doesn't mind doing that. All right, so then, because then it has all its sublevels full of electrons. Anyway, that's just giving you a little reasoning behind this 1 plus charge. So it loses that one valence electron in the 4s orbital. Loses one electron. Okay, now that doesn't mean it necessarily looks like a noble gas. Those are for your main block elements. This is a transition metal, so losing one electron is going to make it have the same electron configuration as, you can say, like nickel, right? But so that octet rule is for the main group elements in S and P's blocks of the periodic table. All right, hydrogen, that's number 1. Why would it have a 1 negative charge? Did it gain or lose an electron? All right, hopefully you said it gained an electron because electrons are negative, so it must gain 1 electron to have a 1 negative charge. Why would it do that? To fill its 1s orbital with 2 electrons. Copper, back to copper. So a lot of transition metals, because when you're ionizing them, okay, so copper, here it is. When you're ionizing them, it'll, well, this is not a good example, but a lot of transition metals will have 2 electrons. Let me just undo all that. A lot of transition metals will have 2 electrons in its s orbital and some number of electrons, 1 through 10, in its d orbitals. So that's why it's, and then this number is usually higher. Let's just say this is like 5 and this is 4. When you're removing electrons from transition metals, their s orbitals get removed, their electrons in the s orbitals get removed first, right? And that's why it's, a lot of times you'll see transition metals with cations of 2 positive charge right there. So it's losing 2 electrons.